Okay, so we're going to start our next unit. This says unit 2, but it's actually unit 4 on solutions. So I've broken, the solutions unit is the second largest unit in the course. Stoichiometry definitely takes up most of our time, but you must have noticed our last 2 units, the properties of matter and gas laws, were really short and quick. So solutions we do spend more time on. So I broke it up into 2 parts. So you'll find part 1 is a little bit more on the theory side of things. There's still some calculations that we do, but we get a little bit more of our background knowledge and understanding of what solutions are. And then in part 2, it's strictly doing calculations with those solutions. So today we'll do our first lesson, which is just a little bit of background info. Some of it you will have learned in the past and some of it will be new. So that today's lesson is pretty short. So let's just look at some definitions, things that you may have heard of before, but we'll redefine them here. So a mixture is a blend of 2 or more pure substances. So we can break down mixtures into 2 categories. We can have heterogeneous mixtures. Okay, so remember this prefix hetero comes up often in science, and it means different, like there's more than one thing happening. So there's our ones in which the different components are easy to see. Types include suspensions, and mechanical mixtures. So let's look at what is a suspension and a mechanical mixture just in more detail. So remember, we're talking about mixtures here. So there's 2 or more pure substances making up this mixture. And when it's heterogeneous, we can identify the different components. It doesn't appear completely uniform. It can either be separated or you can physically see the different components. So let's talk about a suspension. So 3 examples of suspensions. One would be, okay, so let's say flour and water. Okay, so what makes that a suspension? And we'll look at milk and also fog. Okay, so suspensions mean that eventually it will settle out. Okay, so think about milk even. It takes a long time for this to happen, but eventually milk will separate into its components, right? The cream will separate away, and that's why we call it a suspension. So if left for a long enough period of time, it will separate or settle out. Same thing you could say with flour and water. At first, when you mix them, they would appear semi-uniform, but if given time, the flour will settle to the bottom. Fog as well is just water vapor in the air, but as time goes on, that water vapor condenses onto the ground or the grass, and it eventually settles out. So these are suspensions. Mechanical mixtures are kind of more like just physically mixing 2 substances together, and you could actually physically separate them as well. So sand and gravel, for instance, you can clearly pick out the 2 components, and if you wanted to, you could pick the pieces of gravel out. Granola is another one. Like you could separate out the different components of the granola if you wanted, and you can physically see them. A cereal like Raisin Bran would be a mechanical mixture. You can separate the raisins from the bran. Okay, so quite both are heterogeneous. They have different components that are easy to see. With a suspension, you have to allow it time to settle out and separate before those components become visible, whereas a mechanical mixture, right off the bat, you can see the different components and you can physically separate them yourself. Okay, so that's a heterogeneous mixture. A homogeneous mixture, okay, again, you see this, you would have seen this in past science classes. Think of heterozygous and homozygous. Homogeneous means it's the same throughout. Okay, so it's still a mixture, so it's not made of one pure substance, it's made of at least two, but it's so well mixed that you cannot tell them apart. You can't see those different components. So it appears uniform, even though it's made of more than one pure substance. So 3 examples of solutions which are homogeneous mixtures are, for example, salt water, right? If I had a beaker of salt water sitting next to a beaker of just normal tap water, distilled water, you wouldn't be able to tell which one was which. The salt water looks the same as the tap water. It looks uniform even though it's made of more than one pure substance. It's made of both salt and water, but when you put the salt into the water and you stir, it dissolves. And once the salt is dissolved, you no longer see it. Same thing you could say about sugar in water. It will also dissolve and it will look just like regular water, uniform throughout. Another solution, vinegar. You may not realize that vinegar is a solution, but it is actually acetic acid dissolved in water. Okay, so it's only made of 5% of acetic acid and the remaining percentage is just water. So again, vinegar looks uniform throughout. You can't, it's so well mixed you couldn't pick apart the acetic acid molecules from the water molecules. So a better definition for solutions is that they are a homogeneous mixture in a single physical state. Okay, so even though salt water is actually made up of a solid in a liquid, when that solid salt dissolves, it's in one physical state, and that's liquid. Same can be said about sugar in water. Vinegar, on the other hand, well, acetic acid can be in a solid form. It can also be in a liquid form, depending how these two are mixed, but they all appear liquid throughout. So what are some properties of solutions? So one thing we can say about solutions is the particles in a solution are very tiny. They are either ions, atoms, or molecules, none of which are visible to the naked eye. The particles in a solution are evenly distributed. Okay, so it's not like you have a clump of salt over in one corner and the rest of the solution is water. The salt particles, which we'll soon see are actually the ions, sodium and chloride, are evenly distributed throughout the entire beaker of salt water. So if you take 2 samples from the same solution, they will have the same composition. Some terminology that we'll use throughout the unit is, in a solution, the substance that is dissolved is called the solute. So if we're talking about salt water, salt is the solute. It is what gets dissolved. Typically, it's in a lower concentration or a lower amount than the solvent. So the substance that does the dissolving is called the solvent. Okay, so in salt water, water's the solvent, salt is the solute. We dissolve the solute in the solvent. Usually the solute is present in greater amounts, typically. Okay, so in a solution of seawater, just salt water, sodium chloride is the solute, and water is the solvent. A substance that dissolves in another, so if something is able to dissolve, we call it soluble. A substance that is not able to dissolve in another, we say is insoluble. Okay, so what are some various types of solutions that you might come across? So we can have solutions between all physical states, so solid, liquid, and gas. The ones we've referred to so far have been solids dissolved in liquids, but that's not always the case. You can have a liquid in liquid solution. You can have a gas in liquid solution. You can actually have 9 different types doing every combination, right? Solid and liquid, liquid in liquid, gas in liquid, and then you could go through the solids, solid and solid, liquid and solid, gas and solid, and so forth. So you can actually come up with 9 possible combinations. Typically, when you call something a solid solution, that means a solid dissolved in another solid. So solutions formed between 2 or more metallic solids are called alloys. Okay, so that's a solid in solid solution. I'm just going to write that here. Solid in solid. Okay, but we just call it a solid solution. The other word for that is an alloy. An aqueous solution would be when a substance dissolves in water. Okay, now you can dissolve things in other liquids besides water. What makes something an aqueous solution is the solvent is water. Okay, so that's what sets aqueous apart from other liquid solvents. Okay, so solvent is water. Electrolytes are ionic substances that have dissolved in water. When you dissolve something ionic, you might remember this from grade 10 science, it breaks apart into its ions and it's able to conduct electricity because it now has those charged particles basically suspended in that solution. So we call those electrolytes and they conduct electricity. So you might have done that test to see if something was an ionic substance or not by dipping electrodes into the solution and seeing if the light bulb turns on. If it does turn on, that's telling you that it's an ionic substance, and we know it's ionic because it has those ions dissolved and they can conduct electricity. Non-electrolytes are when you have a molecular solute dissolved in water, and these will not conduct electricity. So for liquid solutions, there are limits to the amounts most liquid solutes that will dissolve in liquid solvents. Okay, so a liquid solution is liquid in liquid. Okay, so pairs of liquids which mix in any amounts we call miscible. And pairs of liquids which will not mix together in any amount are called immiscible. So you can probably think of some examples of immiscible liquids. Oil and water, for example, are immiscible. If you mix oil and water together, they will not mix or dissolve. Whereas water and ethanol, which is a type of alcohol, are miscible. You can mix them in any amounts and they will dissolve. When we describe types of solutions, we give the name of the solute state, then the name of the solvent state. Okay, so you will, on your assignment that you're going to do, worksheet 1, there's a chart you have to fill out. Now, typically we do this chart with the help of the textbook, but because we don't have our textbooks with us, we're just going to use Google as our textbook, as well as referring back to these notes. But you'll get to a question on there, question 8, that has a big chart and it gives all the possible solutions. So it starts with solid in solid, solid in liquid, solid in gas, and then you're just to come up with an example of each type of those solution. So you can just simply look those up online. There's more than one example possible for each solution. But when you see that, what you're seeing is a solid in solid. The first word gives the solute, and then the second gives the solvent. Okay, so that's probably not the best example to use because it's solid in solid. So let's say a solid in liquid. The solid is the solute and the liquid is the solvent. So it's given in that order. So for example, sodium chloride, salt dissolved in water, is an example of a solid in liquid solution. Ethanol or alcohol mixed with water is an example of a liquid in liquid solution. Okay, so you can work on solutions worksheet number 1. We're not going to do this review and reinforcement, but you can work on this worksheet here and just simply refer back to these notes for some of the questions, and others you'll have to do a little bit of research to answer.